Let us start digital logic design. So what we will do is we will have complete course in digital logic design which is suitable for GATE, and we'll start with topics that will be covered in this particular session. So what we'll do is we'll just give you theory part and then we'll give GATE questions based on that. So this is how we will be having this complete course. Okay, so let us start. So first I will just discuss out the topics that we will be discussing. Okay, so digital logic design, or in short I will just tell DLD. Okay, so the topics that I will be discussing is, we can write it down as, first one it will be Boolean algebra. In that also we will try to understand what are the different logic gates, like OR gate, AND gate, NAND gate, NOT gate. So many gates are there, so we will try to understand all of them. Okay, then we will also understand K-map. By using that we will try to reduce the functionalities. Then the very good topic is combinational logic or combinational circuit. In that we will be seeing, let's say, half adder, then full adder, then we will be seeing multiplexer, then demultiplexer, then we will be also seeing encoders, decoders. So there are a lot of questions that are being asked in this particular session, is combinational logics. Okay, and at last we will try to understand sequential circuit as well. Sequential circuit. In this particular sequential circuit we will try to see the concept of latch, like what is latch, what is my flip-flops. Then we'll see counters, how to design up counter, down counter, all those things. What are registers, like shift registers and all, and as well as timers. Okay, so all these things we will try to learn in this particular session. Some more topics are like data converters are there, so we'll see data converters as well. Data converters. In that we can see like ADCs, like analog to digital converters, and DAC, that is digital to analog converters. We have lot of logic families these days, like CMOS logic families or TTL logic families. Logic families. So that will be basically CMOS, how to design, like adder, subtractor, all these things, or maybe like AND gate, NOT gate, using the CMOS implementation. And very good topic is going to be number system. Like we have binary number system, hexadecimal, octal, so all these kind of number systems and their algebra that we will be seeing. Okay, and then at last we will try to see microprocessor or microcontroller. So in microcontroller we will see 8085. Sometimes many questions are being asked in this as well. So basically we will try to have the concept of what is my SRAM, then DRAM, then we have PROM, we have state machine as well. So this is very important topic, state machine. Alright, so these are the particular topics that we will be seeing. Now let us start with our Boolean algebra, in this particular session. So what we will do is we will try to see one by one each of them. Okay, so let us say Boolean algebra. You can write down the topic, Boolean algebra. So in Boolean algebra, you have to understand what are the things that is going to be taken into account. Okay, so basically first of all it will be taken as, let us say, if I say 0, it will be considered as low. Okay, and if I say 1, it will be considered as high. So 0 means, let's say, 0 volt, and high means, let us say, 3.3 volt or 5 volt, whichever logic is there, that is how it is considered. Okay, now let us say we have two variables a and b which is going to be entered. Okay, so in that we can say that 0 plus a will be a, because whether you add it a as 1 or 0, it doesn't matter. If you are adding that to 0, it will be always a. Okay, similar to that, I can have Boolean algebra, like expressions like 0 plus 0 is going to be 0, then 0 plus 1 is going to be 1. Okay, then 1 plus 0 is going to be 1 again, and 1 plus 1 is going to be 1 again. So this is how the combination is there. Now if you talk about complements, so complements is nothing but the opposite of that. So if I want to find out complement of 0, so that will be 0 dash. Okay, so that is going to be 1. If I want to find out complement of 1, then it is going to be 0. So 1 complement is 0, 0 complement is 1. If you want to find out 1 complement, again complement, that will become again what? 1 complement is 0, 0 complement is 1. So double complement is going to give you 1. Okay, now there are multiplication law. Let us say 0 multiplied by 0, or 0.0 is 0. Then 0.1 is going to be again 0. 1.0 is going to be 0. 1.1 is going to be 1. So basically this is OR operation, the addition, and multiplication is AND operation. If both are true, then only it is true. If one of them is true or one of them is false, it is definitely false. Okay, so you can consider that if a into 0, it will always be 0. It doesn't matter whether a is 1 or 0. Okay, if it is multiplied by 0, it will always be 0. And if a multiplied by 1, so it doesn't matter 1 whether a is 0 or 1, it will depend on a, so it will become a. So this is a very important expression that you have understood. Now if you talk about laws, let us say a lot of laws are there. So before that, what we will do is, let us say we have the expression a, so we have signal, let us say a, so that can be considered as, let us say 1, or it is 5 volt. So 5 volt means it is considered as 1. Now if it is going to be 0, let's say it is 0, then it will be considered as 0 volt. Okay, so this is how it is considered. If you have b, and let us say it is going to downward, so it will be 0. Okay, so this is how b is considered as 0. So now if I want to multiply both of them, let us say this is my 5 volt and this is my 0. So if I want to multiply both of them, what will be my expression AB? So can you guys tell me? See, this is 1, this is 0. If you multiply them both, 0 into 1 is going to be 0. So till the time they are, and again 0 into 1 is going to be still 0. So this is how AB will be always 0, because both are opposite to each other. Okay, so if AB has to be 1, both of them has to be 1. Okay, now let us talk about laws. Okay, so algebra, Boolean laws or something like that you can tell. So in Boolean laws, we will see commutative law. In commutative law, what happens is, number 1, you can talk about AB is equal to BA. So whether you do it AB or whether you do it BA, both expressions will be same. Number 2, if I talk about A plus B, or A or B is going to be B or A, or B plus A. Okay, so this is the laws that is there for commutative law. Now talking about associative law. So third one is associative law. What happens is, let us say we have A plus B plus C. So all the three summation you cannot do together, you have to take only two of them at a time, right? So whether you do it a plus b and then you added the result to c, this is also equal to, or otherwise you take a and then add the result to b plus c results. Okay, so this is also okay. So this is called as associative law. Similar application will be there for multiplication. Let us say we have a b c, so either you can do it a b first and then multiply with c, or you can do it b c first and then multiply with a. So this is how it is associative law. The very important thing is distributive law. Distributive law. So in distributive law, what is going to happen is, let us say a is multiplied with an expression of b plus c. So this can be equal to ab plus ac. Okay, so a will be multiplied with b as well as c, both. Okay, now let me give you an expression and try to find out like what it is. Okay, so let us say can you tell me laws of Boolean algebra? Laws of Boolean algebra, right? So as I told you already that 0 prime or 0 dash is 1, like complement of 0 is 1 or 1 complement is 0, right? So what will happen if my a is equal to 0, then what will be a prime? So a prime is going to be 1. Or if my a is going to be 1, my a prime is going to be 0. So this is how it will work. Now if a double prime, what will be the result? Again a prime is a prime and then prime of that is a. Okay, so this is how it is done. Now if you see, if you are going to add a plus 0, that just now I told you it is going to be a, then if a plus 1 then whatever the value of a is there, it doesn't matter, the result will come as 1. Okay, now what will happen if I add a plus a? So if it is 0 plus 0, it is again 0, 1 plus 1, it is again 1. So we saw that just now and we can have the result as a. Then if it is a plus a prime, if both are opposite, it is always 1. Okay, either like a can be 0, then a prime will become 1. So this is how you will be having a plus a prime as 1. Okay, now one very important result is there, which is a plus ab. So a plus ab is nothing but, can I take it as a common? So it is going to be 1 plus b, right? And 1 plus b, because here it is remaining 1, so 1 plus b is 1, so it is going to give you a. Understood? So if you are going to add a plus ab, you are going to get the result as a. Now let us say a plus a prime b, then you are going to get result what? It is going to give you a plus b. Okay, so this is how the laws of Boolean algebra was there. Now we have some other laws as well. Let us say De Morgan's theorem and all those theorems are there, so we'll see those. So next is De Morgan's theorem. In De Morgan's theorem, what happens is, let us say we have a dot b prime, then it can be considered as a prime plus b prime. Okay, so what happens? The multiplication becomes addition. Okay, so it is and it is getting converted to OR operation. Okay, then a plus b prime is going to be a prime into b prime. So it is very good method to convert from like AND gate to OR gate or OR gate to AND gate. Okay, so this dot operation, what is the law? Dot operation is going to get converted to addition operation. That is nothing but AND operation is getting converted to OR operation. Number 2, if it is OR operation, it is going to get converted to AND operation, or it is OR from AND, right? So this is what my De Morgan's law. Now what is the other thing? we have to complement each of the variables while removing the complement. So what happens? Let us say third one, what you have to do in De Morgan's theorem, complement each variable. See, this is the formula, a dot b prime is equal to a prime plus b prime. So how will you get it? Complement each variable term while removing the complement, right? So while removing the complement, this complement we are trying to remove, so we have to put complement on each of the variable. Okay, so let me just generalize this term, and we can write the general formulas as, let us say we have a1 dot a2 dot a3, like that. N number of terms are there and all bar is there. Okay, either you can use this bar dash, I mean bar, or this. Okay, both are same. So this can be considered as a1 bar plus a2 bar plus a3 bar, like that. You can go up to infinite, I mean n terms. Okay, then let us say if it is a1 plus a2 plus a3, like that we have multiple number of terms and then bar. Then it can be considered as a1 into a2 into a3 into, like that it is there. Okay, so basically you have to understand that either I write is a prime or a bar. Okay, both are same. Okay, so sometimes I write it like above bar, or otherwise sometimes I write it prime. Okay, so both are same. Now there is something called as precedence rule. Precedence rule means which operation we should do it first. Precedence rule. So in precedence rule, basically the priority order will be, first bracket will be solved. Okay, and then you have to have the AND operation, and then you have to have OR operation. So this is the priority order that you must follow while solving any question in digital logic designs. Okay, so let us have some rules and some of the laws, and we'll prove them as well. So just now you understood that distributive laws was there, right? What was distributive law? Distributive law, what was that? Number one, we had a times b plus c is going to be ab plus ac. So can we prove this? So yes, we can prove that. What we can do is it is very simple, like a into b plus c is equal to, it is going to get multiplied with a, b and as well as ac. So it is straightforward. Let me give you another example. Let us say I want to prove a plus bc is equal to a plus b into a plus c. So this is not looking very straightforward, right? A plus bc is going to be a plus b into a plus c. So how to prove that? So let us see how we can prove that. So let us say we have a plus b into a plus c. So can we do a simple multiplication? So a into a, first of all a into a plus a into c plus b into a plus b into c, right? And ba can be written as ab, that is not a problem. Now we know already a into a is going to be a plus ac plus, I can write it as ab plus bc. Now I can take a common in all the three terms, first three terms. So I can say it as a into 1 plus c plus b plus bc, right? And then 1 plus anything is 1, so it is going to be just a times 1, that is a. So it is going to be a plus bc. So you can see that it is equal to my left hand side. Okay, so this is very simple to prove. Now third law you take into account is a plus b into a bar plus c is going to be equal to ac plus a bar b. So what you have to do is you have to just like multiply each one of them and try to see whether it comes or not. Okay, so it is your job to get this done. Fourth one will be a plus a bar b. So we saw a plus b c, right? Now we will see a plus a bar c. So this is going to a plus a bar b is going to be equal to a plus b. Okay, if you want you can very quickly do that you know already that a plus a bar b is what. If you want to prove, let us say we'll prove it immediately. What will be a plus a bar b? This is nothing but a plus a bar into a plus b, because just now we saw this one a plus bc is a plus b into a plus c, right? Now a plus a bar is 1, so it is going to be equal to just 1 multiplied by a plus b, and 1 into anything is a plus b. Okay, now let us take one more law which is called as consensus law. So consensus law is very important. Consensus theorem. So in consensus theorem we have to have, let us say, number 1, ab plus a bar c plus bc. So it is ab plus a bar c plus bc is going to be ab plus a bar c. So how it is happening is nothing but you have to understand that one of the term was redundant. Okay, so ab plus a bar c. So if you want to prove, let us say we will prove it immediately. So what will happen? We have ab plus a bar c plus bc. Our aim is to get ab plus a bar c. So can we do this? ab plus a bar c plus bc, I can write it down as a plus a bar multiplied by bc, because a plus a bar is nothing but 1. Okay, now if we take it ab plus a bar c plus, what will happen? abc plus a bar bc, like distributing them, right? So bc will get multiplied with each one of them. Now if you see, I can take out ab common from this term and this term. So what will happen? ab into 1 plus c. Then plus I can take out a bar c common. So a bar c, if I take common from this term and this term, then what will happen? 1 plus b will come, right? 1 plus b. Then what is going to happen is it will become 1 plus c is nothing but 1, so it is going to be ab, and then same way it is going to be a bar c. So this is how consensus theorem is proved. Now this was multiplication type, we will have addition type as well. So let us say number 2 consensus theorem is a plus b into a bar plus c into b plus c. So this is going to be equal to a plus b into b plus a bar plus c. Understood? So basically b plus c term is redundant. Okay, so the same way what you had done for the multiplication one, you can prove it this one also. So that's all. Now one more thing, I'll just give you 2-3 more laws, which is going to be a bar plus ab is equal to a bar plus b. If you want, you can distribute them and find it out. So how to find out? Very quickly, you can find out like a plus a bar plus a into a bar plus b, that is going to be a bar plus a is 1 into a bar plus b, so that is going to be a bar plus b. Now one more problem is a plus a bar b plus a bar b bar c plus a bar b bar c bar d. Okay, like that, if some terms are coming and up to a bar b bar, like that up to like x bar y bar z, then what will happen? This will give you a plus b plus c plus very good result. Okay, so up to z. So this is all about Boolean algebra, functions, and like their laws that we have considered today. Now in next session what we'll do is we'll try to solve gate questions based on this Boolean algebra's law, and then we'll proceed next. Thank you.